Hello guys, today we are doing compressors where we are going to show that indicated power of a single acting, single stage reciprocating a compressor is given by the equation there. Then we have to do derivation of this equation. In short, we are asked about the derivation of this equation, and we start from the first point of view from the diagram here, where that we have this diagram. We have to study the diagram first, and we have to get the work done. Now the work done of this diagram in this case, or of a single acting single stage reciprocating compressor, it's given it's the area. Work done will be area or shaded area will be just the shaded area. The shaded area here, we have A, B, C, and D. So it is A, B, C, and D. And by the way, in this case now, our shaded area is divided or is subdivided into some portions. We have first portion, we have the second portion here, which is B, A, B, E, F. The second portion, then we have the third portion here. Now we have to get the different portions. Now, to get the work done of the shaded area, we first have to get this area 1, which is B, C, or E. We have work done as B, C, O, E. Then we add A, B, E, F, A, B, E, F, and we subtract. Now we are subtracting this area, which is unshaded area. That is our area number 3, which is A, D, or F. A, D, or F. Now we are going to find the work done of those areas, or the area of the 3 portions, where now we find B, C, or E. The area for B, C, or E is given by, that is the length times 20, and our length will be P2. This is P2 up to here, then here is V2. And again here, we can have the area of A, B, E, F. But before we find the area of A, B, E, F, we can find the area of A, D, or F. That is A, D, or F. Area of A, D, O, and F. This one will be what? Now we have here, that is P1 multiplied by V1. From here, from A to D will be P1, or from O to D is P1, which is our width. Then our length will be V1. That is V1. Now, let's separate our portion here to work out for the next portion. Now, we can get the portion now of A, B, E, F. Area A, B, E, F. Remember, it is under the polytrophic a polytrophic action where we are getting PV power N equals to C. There is no way you can now find the area of this figure by just getting any, you multiply any. But now we act under the polytrophic reaction or equation here. Then now what we are going to do, this is the compression which was done, and we need to get the work done during the compression. Then now we have work done during the compression. This is the compression. You see now polytrophic equation here. Then we will have the work done S. Now we have to integrate. We integrate P to dV under the limit. You see now we are under the limit V2 and V1. The V2 here and V1 here. So here will be V2 and V1. But we know P. What is our P? From our equation, our P will be equal to what? Now you make P the subject formula here. So it will be C over V power N. And again now, having this one, and we have C. Again we have C here. And our C will be equal to, our C, remember, it's V, PV power N, P, V power N. Now you substitute each to this equation. You substitute for P, then after that you substitute for C. So now our P here will be equal to, this P is CVN, but C equal to PV power N. So it will be PV power N over V power N. But now we are writing this one C in form of P1 V1, because we are here in the form of P1 and V1. So this one will be P1 V1. Then you substitute to our integral, which is work done equals to integral for the limit V2 V1. Then we have P1 V1 power N over V power N. Now we have to get the integral, or integrate in respect to dV. Now we have a constant here. Our constant is P1 V1 power N, and now we are relying on this that is denominator here. So our work done will be equal to, you take out the constant, which is P1 V1 power N, the work done will be equal to P1 V1, then this is V2 V1, then 1 over V power N, then this is under a dV. We know something about this one. Given A, remember when we are doing indices, when we are given A power N, the reciprocal could be 1 over A power negative N, and vice versa. So now if we take 1 over V power N, 1 over v power n will be equal to v power negative n. So this is our reciprocal. Then we say work done will be equal to P1 V1 power n. You integrate limits V2 V1, then this will be V power negative n dV. And then now you can work out this one, and this work done will be equal to P1 V1 power n. And then we have now you now introduce, or you want now substitute the limits. So we have V2, then we have 1 minus n, and this will be minus, we are minusing, or we are taking away V1, that the lower limit, that is 1 minus n. Okay? Then again now, we can take our work done will be equal to P1 V1 minus P2 V2 over n minus 1. That is now the solution of A, B, E, F here. Again, now you come to work done here. We said our work done was B, C, O, E minus or plus A, B, E, F, A, B, E, F, then we minus P1, or we minus A, D, O, F, A, D, O, F. I think we are moving together. Then now you can substitute, because we have BCOE. Our BCOE was P2V2, P2V2 plus our ABEF, ABEF is this one. So we got it as this one. So we substitute this one under enclosure, and we have this is P1 V1 minus P2 V2 over n minus 1. Okay, sorry, here we messed up. Here it was, yeah, P1 P2 V2 was P2 V2 minus P1 V1 n minus 1, because V2 here, it is our upper limit and V1 is our lower limit. So we are subtracting upper limit minus lower limit of integration. Then we are getting this is 2 V2 P1 and V1. Then we subtract ADOF. ADOF was P1 V1. Again now, we continue. We can factor out. If you look at this one and this one, you can group together to be equal to P2 V2 minus P1 V1 then you remain, when you factor out here, because here we have a plus, again we have P2 V2 minus P1 V1 all over n minus 1. We've said that we can factor out p2 v2 minus p1 v1 because here we have and here we have. So we will have, so we can say this is over 1. We can introduce 1 here to get a fraction like this one. So this one will be p2 v2 minus p1 v1. Then here we remain with 1. Multiply by 1. We can multiply 1. Then plus. It will be plus 1 over n minus 1. Then now, this is 1 over 1. This can be 1 over 1. To make it fraction like this one, we can get the LCM here. If we work out for this part, we get the LCM. So here we have P2 V2 minus P1 V1. Then we will have an LCM. Here we'll have an LCM S n minus 1. Then now we have n minus 1 divided by 1 will be n minus 1. Then multiply by 1 will be n minus 1. Then we have plus n minus 1, n minus 1. Then divide by this one, we'll get 1. So this is the case. Now again we can continue and we work out n minus 1 plus n minus 1 plus 1. And remember, this n minus 1 is under, because it's here, it will be under one direction or one area. Then now, when we work out this one, you'll have a P2 V2 minus P1 V1. Then again, under enclosure, you get here, you're remaining with n. You're remaining with n because 1 minus 1 or minus 1 plus 1 will be 0. So this is n over n minus 1. Allow me to rub here. We continue with our equation there. Allow me to rub here. Then you can continue the equation. So we have seen that P2 V2 minus P1 V1 under enclosure, then n over n minus 1 at the enclosure. But P1 V1, but P1 V1 is also MRT1. It's also MRT1. So also P2 V2 can also be MRT2. And then we have now to substitute. We substitute to the equation. Our equation was P2 V2 minus P1 V1, then n over n minus 1. When we substitute here, P1 V1 and P2 V2, P2 V2 will get M RT2 minus M RT1 into n over n minus 1. Now, we can now we can have now we can factor out what is equal or the same factors here. We have MR, we have MR. So here we have MR, true. Then we have T2 minus T minus T1. Then N over N minus 1. If you bring this one to the side, it will be N over N minus 1 MR. Then T2 minus T1. And again, now we can have T1. We can factor out T1 outside. We can factor out T1. If we factor out T1, it means what? We divide by T1 each. We divide by T1 here. So each item we divide by T1. So we have N over N minus 1 MR T1 outside. Then we will have T2 over T1 minus 1. Because of what? If now you want to prove, you can take T1 inside here. We multiply T1 and T1. You divide, you get T2. Then T1 here, you just get T1. So there is no change, or there is no effect of this and this. This one and this one is equal. So these two equations, they look alike. Now, we continue with our working. Now we can solve T2, T1, but we know T2 over T1 is given by P2 over P1 n minus 1 over n. Then now we can substitute this one where there is T2, and therefore we will have our work is now P2 where there is T2 over T1, we put P2 over P1. So we'll have n over n minus 1 m RT1. Then we can have this T2 T1, which is P2 over P1 n minus 1 over n. Then we have minus 1. And this becomes a derivation of our equation under the single compressors. Thank you.